Hello guys, welcome back to Maths Zone African Motives. We are still on our revisions and this is for our grade 9 mathematics. So we are going to consider a June revision. This is a June revision for our mathematics grade 9, and it was out of 75, covering all the topics that we had. All right, the topic or the content is what you had from your term 1. All right, from term 1, and also you're going to consider term 2, meaning to say we've got all numbers, integers, exponents, numeric and geometric patterns, algebraic expressions, algebraic equations, functions, and relationships. This is exactly what we had from our term 1 and term 2, and that was 90 minutes. So you are going to see with the time that we have, how we're going to answer these questions. Make sure you go through the instructions and information, all right, as of the given instructions. The most important part is that your answers are supposed to be rounded off to 2 decimal places unless stated otherwise. All right, so just go through each and every part, and you can also download the question paper if you check the comment section. All right, I'm going to put a comment which has got the link where you can download the question paper in the comment section. Also, you can check the description of the video. All right, if you check the description of the video, you are going to also see or notice a link which you can use to download the question paper. All right, so like I said, I'm not going to waste your time. This is our section A. Question number 1. Various options are provided as answers to the following questions. Choose the answer and write only the letter A to D next to the question number, right? So we're given this 1.1. Which of the following is irrational number? An irrational number, the one that cannot be written in the form of A over B. We cannot write it in this form. Those are typically square roots of numbers, square root of 2, square root of 3, square root of 5. Those are irrational numbers, numbers that are not exact. They are not what? Exact. So the best answer there was going to be the square root of 2. 3 over 4 is already in the form of A over B. So we have got what? A rational number in this case. This is a rational. It can be written in the form of A over B. 0.75 can also be written in that manner. 0.75 is equal to what? 3 over 4. It is the same as the 3 over 4 that we have. Minus 5 is same as negative 5 over 1, can be written in the form of what? A over B. So the only one that is not exact is the square root of 2, right? If you look at this one, guys, it's an endless decimal. So that is what? Irrational number. All right, let us move on to 1.2. Calculate this. All right, we are given a negative and a negative here. So that was going to give you a positive. So you've got minus 3 plus a 7 plus a 4. All right. If you consider addition, as it is easier for you to add, you can simply add those two. That is 7 and what? 7 and 4, of which this is section A. You can just use your calculator to simplify everything. Minus 3 plus a 7 plus a 4 like this. That was going to give us an 8, which is what? Which is on A. Or you can simplify, like I said here. If you add 7 and 3, that was going to give us 11. Then 11 minus 3, that is what? That is 8. As we can see, we are going to obtain the same answer, which is what? Which is 8. So the best answer was going to be A. All right. Number 1.3. Which statement best describes the rule of the pattern? So we have a pattern here that we're given 1 over 3, 4 over 3, 7 over 3, and so on. So if you are going to notice between these numbers, all right, here they're saying add 2 to the previous term to get the next term. Is that possible? 1 over 3, then let us add what? 2. It is going to give us 2 and 1 over 3, which is same as 7 over 3. This is wrong. The next term is what? 4 over 3. All right, so this one is wrong. Add 1 to the previous term to get the next term. All right, let us add 1 plus 1 over 3. That is going to give us what? 4 over 3 plus 1. All right, let us add 1 again. That is what? 7 over 3. Exactly what we have here, plus 1. That is going to give us what? Again, 10 over 3. Exactly. So if we add 1 here, add 1 to this, you're obtaining the next term. The next term, that is, there is a difference of 1 throughout these terms. So this statement is what? Is correct. All right, numerators are odd numbers. This is not about the rule. This does not describe the rule. Denominators are equal to 3. That's not a description about the rule. The rule is what are you adding to get the next one, or what are you multiplying to get the next term, not about the denominators or the numerators. That was not important. All right, 1.4, what is the expression in simplest form? The expression x minus 7 squared means that we have got two brackets being expanded of x minus 7, two brackets that you're supposed to expand. So using the FOIL method, you can expand the binomial expansion, this where you're going to have x and x, all right, for the first terms, x times x, that is x squared, then the outer, the x to the what? Negative 7. X times negative 7, negative 7x. Then we've got the inner part, which is what? Negative 7 times x, negative 7x. Then the last, which is negative 7 to negative 7. That was going to give us positive what? 49. And that is x squared. Collecting the like terms, we've got negative 7x and negative 7x here. So collect those two. That is going to give us negative 14 minus 7. Minus 7 is what? Minus 14. Or you can use a calculator. Minus 7 minus a 7 is what? Negative 14. So this is what we have. And the best answer was going to be what? Where we've got, this is on A. All right, so the best answer there is what? Is A on 1.4. Let us move on to 1.5. 1.5, you are given what is the value of A in the equation? This, right? There are two brackets equated to 0. So we know that the product of two terms to be equal to 0, it is either A is equal to 0 or B is equal to 0. So this is the concept that we are simply going to use. It is either the first bracket of what? 3A plus 2 is equal to 0, or the second bracket of what? A minus 6 is equal to 0. So let us solve for A. We can subtract the 2 since we've got a positive here. So subtract 2 both sides. You're going to remain with the 3A. 0 minus 2, that's minus 2. Then divide by 3 since we've got what? A product here. So A was going to give us negative 2 over what? Over 3. Okay. On this one, simply take the 6, the negative 6 to the other side, or simply add 6. There's a minus here. So the opposite is to add. Simply add what? 6 both sides of your equation. So this can cancel. You're going to remain with A in this case. So that's our A is equal to 0 plus 6. That's what? 6. So the answer is supposed to be minus 2 over 3, or A is equal to what? A is equal to 6. So the best answer is D. We've got minus 2 over 3 and what? And 6. All right, so that was going to be the best answer on 1.5. Then let us move on to section B, which is considering question number 2. Question number 2, 2.1, calculate the LCM of 825 and 920 using what? Prime factorization. So that is our 2.1. We're going to need to find the LCM. So let us start with 825. Remember, prime factorization, prime numbers. You're talking about 2, 3, 5, 7, 11, 30. These are the prime numbers that we do understand, and so on and so on. So let us start with the smallest one, which is 2. It is not a prime factor here. We cannot, we are not going to have an exact value. If you divide 825 divide by what? By 2 is going to give us a fraction. Remember, you're supposed to obtain what? An exact value. All right. So let us move on to 3. To 3, it is going to be what? 825 divided by 3. That is an exact value that we are obtaining here. So meaning to say, we are going to start with the smallest prime number, which is what? Which is 3. All right, so divide by 3, we saw that it is going to give us what? 275. Again, we are going to try that 3 and see, all right, if it is going to work, but 3 is not going to work here. 275 divided by 3 is going to give us a fraction, so that is not going to work. So you move on to what? To 5, all right? 275 divided by 5, that was going to give us 55. So 5 is going to work. So that's 55. You move on. Try again 5, but as you can see, the last value is 5, so it's going to work. 55 divided by 5 is 11. All right, this is going to give us what? 11, where 11 is what? A prime number. So there's no way of trying any of these numbers. Just use that 11 as it is, since it is what? A prime number. So thus, 825 can be written as 3 times 5 times 5, which is what? 5 squared times 11, like this. Okay, so then we move on to 920, doing the same thing. We're going to start with the smallest prime number. Of these prime numbers, start with 2. So 2 is going to work since we've got a 0 there. 990 divided by 2. All right, this is going to actually work. That is going to give us 400 and what? 495. So try 2 is not going to work this time. You can see we have got a fraction here. So we are going to use another 495. We move on to the next prime number, which is what? Which is 3. So as we move on to 3, this one is going to work. So divide by 3, we obtained what? 165. Again, let us try this 3. All right, it is going to give us an exact value after dividing by 3. So 3 is going to work. So here by 3, we are going to obtain 55. So we can see that we worked with 55 here before. So thus we are going to repeat those numbers. 5 into 55, that is 11. Then 11 again is going to give us the 1. So thus 990 is equal to, that's 2 times 3 times 3, which is 3 squared, times 5 times what? 11. This is what we have. What you are being asked there is to determine or to calculate the LCM, where we do understand that the LCM, if you write the factors, the prime factors in exponential form as we have here, you are going to consider where you have got the highest power, where you've got what? The highest power of all, right? Of all the prime factors found in both numbers. Highest power of all. That is the most important part of all what? Prime factors, of all prime factors found in what? In both numbers. In both numbers. So from the numbers that we have, where are we having the highest power of all prime factors found in both? So we look into these prime numbers. The first one is 2. It is a prime number that we obtained. There is also 3. There is a 5. There is what? 11. All these prime numbers are supposed to be part of your answer. But as you consider them, take where there is what? The highest power. So let us start with the 2. Where do we have the highest power? It is that only this one, this one. So that is 2 times 3. Where do we have the highest power on 3? It is 3 squared. There is a 3 here, but we have got another 3 raised to the power of what? To the power of 2. So that's 3 squared times. The next prime number is 5 according to what we have on these numbers. There is a 5. But which one has got the highest power? 5 squared. 5 to the exponent of what? Of 2. All right, times. There is 11 on these numbers, but which one is got the highest power? They have the same power to the power of 1. So just write 11 as it is. All right. So this is our LCM, which we can use our calculator to determine. 2 times 3 squared times 5 squared times what? 11. That was going to give you 4,950. All right. So that's 4,950 as our LCM. All right, just like that. So you consider where you've got the highest power of all prime factors that are here. They must be on your answer. If you leave any prime number here from these ones that you determined here on the LCM, know that your answer is wrong. It is the HCF where you consider where it is common between the two. You must consider where it is common, and you take where you've got what? The smallest power. The smallest power, and they must be common. It is for the what? For the HCF. But as for the LCM, highest power, for all prime factors found in what? In both numbers, just like that. All right, so that was it. You have got your LCM. Let us move on to the other part of our question, which is 2.2. A food supply, it lasts 15 days for 20 people. That's 2, all right? 15 days. So here it's about the number of what? The number of days. Then here the number of what? The number of people. So 15 days equivalent to 20 people, all right? How long will the same food supply last for 30 people? Number of people on this side. So what about when you've got 30 people and you're using the same? So this type of a question is like we are dealing with a rate. We are saying or considering proportion as indirect proportion. 15 people, all right? I mean 15 days equivalent to 20 people. So the more number of people, they will take lesser days. They will take, guys, if you're two of you, all right, you are eating, let's just say same amount of KFC, all right, same amount of KFC. Let's say you bought, let's say we can say 3 piece, right? You are two of you, you are eating 3 piece. Then you are now 10, guys, 10 of you eating the same 3 piece of KFC. How long are you going to take? You're going to take less time to finish. If you are two, you're going to take more. So this is an inverse proportionality. Inverse proportion. It does not increase. It is like for an increase for one, the other one reduces. When the other one is reducing, the other one increases. That is the concept of what? That is the concept of an indirect or inverse proportion. Indirect. This is indirect. Because this is going to be less. It was supposed to be what? It was supposed to be more. The bigger value here was supposed to be to give us what? A bigger value. That is direct. But if they oppose to say we've got a bigger value, but what you're supposed to calculate is less compared to what you're given here, then it is what? Indirect. All right. So let's say this is X. We can find, remember, indirect, you multiply corresponding as it is like this. All right, this is for indirect. If it was direct, you're going to take like as you cross multiply. All right, but for indirect, you take it this way. So that's X times 30 is what? 30X must be equal to 15 times what? 15 times 20, just like that. So 30X is equal to 15 times 20. that was going to give us 300. So divide by 30. Since we have a product here, we're going to find the value of x, and that was going to give us a 10. You can even use a calculator here. 300 divided by 30 is what? Is 10. So x represents the number of what? The number of days. So we're talking about what? 30 days 10 days. X represents days. So it's what? 10 days. So that's a food supply. This one, which is for 10 days, is going to last for what? For 30 people. So that's less to what we saw before. If they are 20, they are going to need what? 15 days. So 10 days, that's less to compare to what we had. So that's the condition. So that's a food supply. A food supply lasts how many days? It lasts 10 days, as we obtained here. 10 days for what? For how many people? For 30 people. For 30 people, as we are given here that they are 30. So they are going to need what? 10 days. So that was the condition of our question. In this case, indirect proportion can actually be applied the way that we do understand. So many ways that you can actually have in a case like this. All right. Some can simply use it this way. All right. If 15 is equal to 20, all right, I talk about days. This is people. What about 30 people? How many days? We know that this is less. You take the smaller value over the bigger value. It's less. So smaller value over bigger value times what you're supposed to calculate the number of days. So it is 20 over what? Over 30 times what? Times 15. Direct like that. This is going to give us what? This is going to give us 10 days. All right. So your understanding, guys, any way that you understand. All right. Let us move on to 2.3. 6,800 is invested for 6 years. So you're talking about the money being invested as our principal, 6,800. For how many years? For 6 years. That is the value of n, 6 years. All right. And grows in value to this, that is the accumulated amount, was 12,500. The accumulated amount it accumulated to. Calculate the interest rate. If the interest is compounded annually, we are dealing with what? Compounded annual. What is the interest rate? If you are dealing with the compound interest where amount is equal to P into what? 1 plus R over 100 to the exponent of N, compound interest formula, where A is the accumulated amount of what? 12,500 is equal to the principal, 6,800 into 1 plus, remember you're supposed to calculate the value of R in this case. So that is R over 100 to the exponent of N, the number of years. How many years? 6 years. All right. We want to find the value of R. Look where it is, guys, inside the bracket. This is inside the bracket. So we must get rid of everything around the bracket. First, that is the 6,800 outside as a product. Divide by what? 6,800. 6,800 divide by what? 6,800. So that was it. This is going to cancel. So you have this in the bracket 1 plus R over 100 to the exponent of 6 in the bracket. Everything is inside the bracket raised to the exponent of 6, which is equal to this, all right? Just rewriting this way, all right? I haven't changed anything. Yes, you can reduce these, or you can just leave it as it is like this, or you can reduce that one. It is not a problem at all. Or you can just leave it as it is. So remember, we are supposed to calculate the value of R, which is inside of the bracket. And what is affecting this time is the exponent of 6. So how do we get rid of this exponent 6? We are supposed to introduce the 6th root of that. It is to the exponent of 6. You put 6 inside the root sign to get rid of this 6. But what you do on the left-hand side must be done also on the right-hand side. So that is the condition that you're having. The sixth root, these two, they are supposed to correspond. With that, it neutralizes or removes the root sign that you're given. So you remain with this part under the root sign, which is what? 1 plus. So you're going to remain actually with 1 plus r over 100, all right, is equal to this, which is the sixth root of what? 12,500 over what? 6,800. So what you can do here to find the value of r is to simply get rid of the 1 which is being added, this 1 plus. So we can simply subtract the 1, subtract the 1. So we're going to remain with what? R over 100 is equal to this. All right, I'm just going to repeat as it is, 12500 over this. All right, minus 1. So to find the value of r, since we've got a denominator, this is over 100. So you're going to multiply by what? 100. Meaning to say whatever that you're going to obtain here, multiply by 100. That is the idea. So that was going to give us the rate that was taken for this compound interest, all right? So this is what you need on your calculator. You are going to need the sixth root of, all right? So the sixth root from here, this one, you're gonna need shift to press this, all right? So that is to have that. So that is shift, then gonna have the sixth root of what? The sixth root of which I was just supposed to put a bracket before. All right, let me just put the bracket here. The sixth root of what? 12500 over what? Over 6800, like this. Then let us move aside. Let us move again aside. Subtract 1. Close the bracket. Multiply by the 100 outside of the bracket as it is. You are going to obtain this 10,6 7 and so on. But remember, our answers to 2 decimal places, if not stated, we are going to have to 2 decimal places, 2 decimal places, which is 10,68. So that was going to be 10,68%. Remember, this is the rate which is taken per annum, per year. All right. So that was what we are going to have from the compound interest formula. From our compound interest formula, it was just a direct question. As we can see, just a matter of playing around with what you are given. Question number 3. From question number 3, you are given here, calculate the following without the use of a calculator. Without the use of a calculator, show all calculations on what? On 3.1. Right, let us consider 3.11. All right, this is direct, guys. It's just minus 5 squared, minus 5 times minus 5. Remember, negative times negative gives us what? A positive. So it was going to be what? Positive. 5 times 5 is what? 25. So this is positive to a negative is what? Negative. So the answer was simply going to be negative 25. All right, direct as it is. Let us move on to another one, 3.12. You are given a product. In this case, it is, let me just rewrite so that you can properly see. It's 5 into 2 into 4 minus 5 into what? 2 minus 4 into 2, like this. Everything over minus 5 minus 2. So you're going to consider the brackets, all right? Let us just consider multiplying these together. 5 times 2, that is 10. And 10 times 4 is what? Is 40. Okay? So you simply multiply that. Then here we've got what is inside of the bracket. So according to your board mass, yes, you have to simplify the brackets, but inside that bracket, there is another bracket where you have to multiply the 2 here. There is minus 2 times what? Times, minus 4 times 2. So it was going to be minus 5 into 2 minus 4 times 2, which is what? Minus 8. So this is gonna give us negative 8 over what? Minus 5 minus 2, that's what? A negative 7. You are simply going to the what? To the left. Minus 5, then you move minus 1, that's minus 6, minus 2 to minus 7, like that. All right. Then simplifying the bracket, we are still on the brackets. We have got 2 minus what? 2 minus 8. And that was going to give us what? A negative 6. So that's minus 5 times negative 6 over negative 7. And that's 14 minus times a minus gives us a positive. Then you multiply 5 times 6, which is what? Which is 30 over a negative 7. 40 plus 30, that is what? That is 70 over negative 7. And this is going to give us a negative 10. That's 1, 0, negative what? Negative 10 at the end. All right. You can even use a calculator to divide this. When they say do not use a calculator, they mean on the simplification of this part as it is, just to evaluate everything with a calculator. But multiplying 4 times 5 times 4, 5 times 2 times 4, you can even use a calculator there. As long it is a stage by stage, you can use, not to say everything, you evaluate the whole question as it is with a calculator. No, that is what you are not allowed to do. All right. But other simplifications does not mean you cannot do that. All right. What is the cube root of 125 on 3.13? The cube root of 125 is what? Is 5 minus the square root of 9, which is 3, plus 1. The square root of 9, the number that multiplies itself to give us what? A 9. All right. Over the square root of 121, that's from 11. 11 times 11. All right. Minus the square root of 64, which is 8. So that was it. Then adding the numbers on the numerator, 5 plus 1, that is 6, minus what? Minus 3. 6 minus 3 gives us what? Gives us 3 over 11 minus 8, that is 3. Then 3 over 3 gives us what? Gives us a 1. You are done. So guys, as you can see, it was a direct question. So make sure you download the PDF, download the question paper so that you can properly see the questions that you are given. All right. Let us simplify 3.14. Negative 4 times negative 2, negative to negative gives us what? A positive. So that was 8 over 8. 4 times 2 is what? It's 8. It's what? It's a positive. So that is it. Plus minus 2 to the exponent of 3. Minus 2 times minus 2 times minus 2. That's 4 times negative 2, which is what? Negative 8. So it was going to be negative 8 over negative 1 squared. That's a positive 1. Negative 1 times negative 1. Negative times negative is a positive. So that's it. 8 over 8 gives us what? A 1. Plus minus 8 over 1. That's a minus 8. Remember, guys, k over 1 is equal to k. So meaning to say any constant, as long as you're dividing by 1, you're going to obtain that. So here it's 1 plus minus 8 is going to give us a negative. You are moving 8 steps to the negative, guys. You're going to end up at what? Negative 7. So like I said, even to use a calculator, you are not forbidden to do that on this part, all right? You can simply evaluate that way. So that was it for 3 marks. Then 3.2, simplify the following again without the use of a calculator. Write the final answer with what? Positive exponents. We do understand when a negative is raised to the exponent of an even power is going to change to a positive. That's exactly what is happening to a negative here. To the exponent of 2 is going to change to a positive. So that's no need of us writing that. 7 to the exponent of 2, that is 49. Everything is raised to the exponent of 2. P to the exponent of 2. What about Q to the exponent of 5 is going to be also raised to the exponent of 2. So you simply multiply the exponents. 5 times 2, which is what? Which is 10. So that's Q to the exponent of 10. Every part, you raise negative 7 to the exponent of 2, P to the exponent of Q to the exponent of 5 to the exponent of what? Of 2, the one that is outside. So that is what you are going to obtain at the end. All right, then let us move on to 3.22. In this case, we have got an exponent of 3 outside, which is very true. But let's consider what is inside the bracket. It's a product. So a product, we can simply multiply these two, x and what? And 2x. Remember, when you're multiplying the numbers of the same bases, you simply add the what? You simply add the exponents. Let's say you're multiplying these numbers of the same basis, you simply add the exponents. So here it is a 1 on 2x, it is to the exponent of what? It is to the exponent of 1. It is the same as it is raised to the exponent of 1 when the exponent is not written. All right. So that is the idea. So guys, why is it now doing this when I want to write? This is also a 1. So it was going to be simply x to the exponent of 1 times 2x to the exponent of 1. You add the exponents 1 plus what? Plus 1, which is 2x squared. So this is going to be 2x squared, but raised to the exponent of 3. So we are back to the same concept where there is an exponent in this case outside, which affects everything. 2 is raised to the exponent of 3, which is going to give us what? Which is going to give us 8. Then x squared is also raised to the exponent of 3. So you multiply exponent to exponent. So 2 times 3 is going to give us what? 6. So that was 8x to the exponent of 6. Just like that. So you see, guys, they'll ask these typical questions just for the sake of revision. Do revise, all right? They want you to revise all the basics, understand all the basics. Even if you are to check on this one, you are given -3, then there is a to the exponent of 1, -1, like this. All right, let's just try and see what's happening here. -3b to the exponent of -5 to the exponent of 2. All right, that's our 3.23. So if you're to consider, the concept is still there, the exponent concept. Here, the exponents, all right? So 3, -3 is not an effect. It's just going to remain as it is. But the a is to the exponent of -1 to the exponent of -3. So your back exponent multiply is going to be -1 times -3. That's a positive what? A positive 3. Then b squared and what? Exponent of -3, like that. So you multiply again, it was going to be b to the exponent of what? -6. All right, times, here we're just going to, it's 1 and 1. So simply 1 times -5, that's a -5. 1 times -5, that's a -5. All right, so that's it. We have applied our exponent. Everything over what? A negative raised to an exponent of an even changes to a positive. Remember that. Then 3 squared is going to give us what? 9. All right, so now a positive 9. Then exponent to exponent, you multiply. -5 times 2, that's a negative what? A -10. So it's going to be b to the exponent of a -10. All right, let us consider what we have on the numerator, in the numerator, like these terms. Since it is a product, you can, yes, multiply this, but consider that where you've got the same basis, you add the exponents. Remember our law, x to the exponent of m times x to the exponent of n gives us what? X to the exponent of m plus n. So if you're going to multiply, it was going to be -3 times 1, which is -3. But as you consider the base of a here, this is a, this is a. So you add the exponents 3 to negative what? -5. So that's a to the exponent of 3 plus what? A negative what? A -5 here. Then we move on to b to the exponent of what? -6. then we add the exponent, which is what? Negative 5. So we're going to add the exponent. We are adding the exponent, but the exponent that we are adding is what? Negative 5. All right. Everything over the denominator as it is 9b to the exponent of what? Negative 10. So this is it. Let us simplify as you are to consider this plus and minus is going to give us a negative. That's 3 minus 5, which is what? A negative 2. Okay. Then considering here b also a negative here, so that's minus 6 minus 5, which is what? Minus 11. So that's b to the exponent of negative 11 over 9b to the exponent of what? Negative 10. So that is it. Let us divide here. These numbers can simply be divided, guys, all right? 3 into 3, that is 1, into 9, that is 3, or you can even use a calculator to just evaluate that, guys. Minus 3 over what? Minus 3 over 9 is going to give us what? Minus 1 over 3. So minus 1 over 3. Then A is going to be on its own like this. But B is to be what? Is to be simplified as we have got the same base, but this time is under a division. So under a division, you are going to subtract the exponents. If you are dividing what? The same bases, you have to subtract the exponents. So that's b to the exponent of negative 11. We subtract the exponent, which is what? Negative 10. So that is the condition applying the laws of exponents now. All right, so you're going to have minus 1 over 3 times, all right, a to the exponent of negative 2 times b to the exponent of what? This is negative, negative, that's a positive. So minus 11 plus 10 is what? Minus 1. So that's going to be b to the exponent of negative 1. All right, so that is the condition, but we are supposed to leave our answer as what? Positive exponents. All right, leave your answers with what? Positive exponents. So in our case, we can see that these are written as what? Negative exponents to the exponent of negative 2 to the exponent of negative 1. We've got what? Negative exponents. So we have to get rid of these negative exponents. From which concept? Any number when raised to an exponent of a negative can be written as 1 over x to the exponent of n like this. So meaning to say, I was simply going to rewrite as minus 1 over 3 times 1 over a squared times 1 over b, all right, to the exponent of 1, which is same as what? Which is same as a b. So I'm simply going to multiply the numerators together. Negative 1 times 1 times 1, which is what? Negative 1 over 3 times a squared times b squared in the what? Denominator. That's 3a squared what? B. So that was going to give us this answer, which is what? Negative 1 over 3a squared b. Negative 1 over what? 3a squared b. Just like that. So you can see, guys, that is what you're going to have at the end. Just try to be very careful in your simplification. Try to be very, very careful. All right. We can see that it is just a repetition, guys, just a repetition throughout. All right, let's consider another part of our question, which was now on 3.24. All right, 3.24. Let us just consider this part quickly and see what we're going to have here. That's 3.24x over y plus y squared over x squared. All right, to the exponent of a negative 1. So we can see that in order for us to use this exponent, we are supposed to have a single fraction a over b to the exponent of negative 1 is the same as b over a raised to the exponent of 1. So meaning to say, if this is negative n, this is going to be a positive n. That is the concept. Simply interchange or vice versa the fraction that you have. So in order for us to have a over b, we are supposed to express this one as a single fraction, express as a what? As a single fraction. So it must be a single fraction. So as a single fraction, I'm going to have the LCD of the denominators, yx squared, which is the same as what? X squared y. All right. So this is the same as x squared y, like this. Let's divide. This and this is going to cancel. You remain with x squared. Multiply to the numerator x squared times x. That's x to the exponent of 3 plus, if we divide to this denominator, x squared and x squared was going to cancel. So we are left with y times what? Y to the exponent of 2, which is y cubed to the exponent of 3. All right, so this whole part is raised to the exponent of what? A negative 1, like this. So what can we do from this part? As we can see, we have that single fraction which is written in the form of a over b to the exponent of a negative. So we can simply interchange this fraction to get rid of this negative. So it is going to be given as the denominator as what? The numerator, x squared y over what? The denominator of over this. It is now our denominator. The numerator is now our denominator raised to the exponent of 1. So guys, anything to the power of 1 remains as it is, like that. All right, so there's no need of you writing this to the exponent of 1. Just leave it like this, just like that. All right, so it was a simple question. As you can see, it was just a matter of playing around with the question, playing around with the information that you are given. All right, so that was it. Let us move on to question number 4. Question number 4, you are given here. All right, let's see what we got. We are told that 4.1, calculate the value of the unknown numbers in the flow diagram below. Unknown, all right, so they are unknown terms in this case, which is A and what? And B. Those ones, they are unknown. They are being, all right, they've got the input values. All right, we've got our input and here we've got our output, and this is our rule. So what simply happens here is how can you calculate the value of A? A represents what? That is the question. A represents what? A represents what? So A is the output. If we check here, A is the output. For which input? For input of 12. If our input is 12, remember the input represents the x values. So in place of x in this, if you place that x, 2 over 3, you place your x as the input, which is what? Which is 12. All right. Then you add a 4, you are going to obtain the output, which is what? Which is our A. So that was for A. So A is the output, just like Y is equal to represent the Y value. All right. So let us simplify this. And that is our value of A, 2 over what? 2 over 3 times 12 plus what? Plus 4. So that was going to give us a 12. Let's go back to the normal mode. All right, that's a 12. So A is equal to what? A is equal to 12. What about this unknown value, which is B? It is the input value representing the value of X. If I substitute this in place of X, I'm going to obtain what? I'm going to obtain the output, which is 24. So form an equation from there. 2 over 3x. Our x is represented by what this time? By B. If I substitute this B into X, all right, plus a 4 as it is, I'm going to obtain the output. I'm given the output this time, which is what? 24. So I formed an equation where I need to solve for what? Where I need to solve for B, all right? So let us solve for B in this case. This is a linear equation. So let's get rid of this 4. Simply subtract this both sides. So I'm going to obtain 2 over 3b is equal to 24 minus 4, which is what? Which is 20. All right, so to obtain the value of b, I can simply cross multiply 1 times 2b, that is what? 2b. 3 times 20, that is what? 60. Divide by 2 by 2. So b is going to give us what? 60 divided by 2 is what? Is 30. So that is it. The value of a was going to be 12, and the value of b was going to be what? Was going to be 30, representing b representing the input. All right, b is on the input, whilst a is on the output, just like that. All right, 4.2, you are given to study this table that we are given, and from that table, calculate the value of a from there. All right, we can simply study this table and see what is happening in terms of the values. All right, this is -2, -1, 0, 1, like just like terms 1, 2, and so on. Here we check the differences between these two. 7 minus 10, that is what? -3. 4 minus 7 minus 3. 1 minus 4 minus 3. You can see there's a difference of -3, -3, -3 throughout. So if we add -3 here to this one, you are going to obtain the value of A. Or what you just said here, the same to say, you must obtain a difference of -3 if you say a minus 1, just like what you have here. 7 minus what? 7 minus 10 gives us -3. So here, if we say a minus what? A minus 1, we must obtain what? -3. So what is the value of a? Just like that. So you take this -1 to the other side, or simply add 1 both sides. So -3 plus 1 is what? Is -2. So a is equal to -2. Or you're going to determine the rule first of this, all right? The rule of the given the equation that you're going to form, then from, guys, you can do that, but using the number pattern concept, just look into the what? The difference. All right. 4.3, complete the following sequence by filling in the next two terms. It is the same as what we just did from that table. You just need to consider what is the difference, what is happening between these two terms, between the terms. Here, if we check 3 minus 2, 1. 5 minus 3, that's a 2. All right. 8 minus 5, that's a 3. 12 minus 8, that's a 4. So you can see that these numbers, the differences are increasing by 1. There's a difference of 1, also a difference of 1, difference of 1, difference of 1. So the next one was going to be what? 6. So simply meaning to say 17 plus what? 6 gives us the next term. This is what it simply means. 17 plus 6 is going to give us what? To add here. We simply have to add. 17 plus 6 is going to give us what? The next term that is following. That is the concept. All right? From what we are given. So that is going to be 23. All right. So the next one, as you can see, they're increasing by 1 by 1. Now it's 6. It increases by 1. So it's going to be a difference of 7. 23 plus what? Plus 7 is what? Is going to give us a 30. So the next two terms, 23 and what? And 30. So it was going to be 23 and what? And a 30. You just consider what you're given. Every pattern, just consider, like 4.4, consider the following pattern, determine the general rule, the nth term. Consider, do you have a constant ratio or a constant difference? Start with the constant difference, all right? So let's start with the difference. This is our T1, our T2, our T3. Difference of what? 10 minus 3, a 7. 17 minus 10, a 7. This one, a 7 again. So we can see that this is simply a numeric, all right? A linear pattern where our Tn is given as what? An plus what? Plus b, where a is the difference. We've got a difference of what? A difference of 7. So that's 7n plus b. So you have to find the value of b by using any corresponding terms. Remember the concept from our introduction. T1 equals what? Equals 3. So if T1 equals 3, it means I'm going to substitute 3 is equal to 7 times our n is 1. Our n T1, n is 1. So we must obtain what? A 3 plus a b. So let us solve for b. 3 is equal to 7 times 1. That's a 7 plus b. So solving for b, we're going to take this to the other side. 3 minus 7 is minus 4. So that's the value of b, which is what? Minus 4. So therefore, our Tn from here, which is 7n plus b, we're gonna write this as what? Tn is equal to 7n plus minus 4. Remember, our b is minus what? Minus 4. So that was it. 7n minus what? Minus 4. In case of having our general what? Our general rule. All right, so that was it on 4.4. 4.5, you are given to consider the following designs, all right, made of what? Hexagons. They are made of hexagons. All right, so the first one, they are 1, 2, 3, 1, 2, 3, 4, 5, 6, and so on. So how many hexagons are there in design 5? We do not see design 5, but we can tell from what we're given here to say, let's say this is our design. Then we have got the number of what? Of hexagons like this. Design 1, there are what? 3 hexagons. On design 2, there are 6 hexagons. On design 3, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them. What is happening between these 3, 6, 9, and so what is happening? 3, 6, 9, and so on. It is the design times 3. 3 times 1, 3 times 2, 3 times 3. So if it is design 1, 3 times 1. Design 2, 3 times 2, 3 times 3. So what about design 5? 3 times what? 5 is equal to 15. So we are going to obtain 15 hexagons from there. All right, so design 5 is going to have what? 15 hexagons. All right, or you can simply work with this to say there's a difference of what? Of 3 here. 6 minus 3, that's a 3. 9 minus 3, that's a 3. There's a difference of 3. So the next one, we are going to simply add a 3. 9 plus 3, that's a 12. The next one, which is the fifth one, we add a 3. All right, so 12 plus 3, that's what? 15. So you know that the answer is 15. So many ways of answering this. 4.52, determine the general term. All right, we have already said this, guys. We saw that there is 3n, 3 times 3 times this, like the first pattern or the first design you multiply by 3, the second one by 3. So for any number of designs, it is going to be Tn is equal to what? To 3n. Or you can use the formula, since we can see that there is a common difference of what? Of 3. A common difference of what? Of 3. Or a constant difference of what? Of 3. So that's you're dealing with a numeric where Tn is equal to what? An plus b. So Tn is equal to our a is the what? The common or the constant difference of what? Of 3. That's 3n plus b. Find the value of b. T1 equals what? Equals 3. So if T1 equals 3, it simply gives us 3 is equal to 3 times what? 3 times 1. Our n, T1, n is 1. So find the value of b. 3 is equal to 3 plus b. Take the 3 to the other side or simply subtract 3. So b was going to give us what? 3 minus 3, that's a 0. So here you are going to put a 0 in place of what? In place of b. So therefore, our Tn was going to be 3n, all right? 3n plus 0 is what? Is 3n. There is nothing that you're adding there, all right? So that was the condition. That's your Tn. So many ways of finding this, guys, all right? So many ways. If you're given this, all right, which design we will have 450 hexagons, the designs, that's design 1, 2. So you're talking about what? N. What will be the value of n if our Tn is what? 450. So you simply work out from the Tn that you have from what? percent 4.52. Remember, our Tn is what? 3n. So it must be equal to 450 so that you can have the value of n. Solve for what? Solve for n in this equation. Divide by what? Divide by 3, like that. So that is going to cancel. 450 divided by 3 is going to give us what? Is going to give us 150. So meaning to say, that's the 150th design, which will have 450 hexagons. All right. Simple like that. Let us move on to question number 5. 5.1, given this expression, 5.1.1, how many terms are there in the expression? Just count 1, 2, 3, 4. So there are what? 4 terms. And 5.12, what is the coefficient of the third term of these terms as you're counting 1, 2, 3, and so on? What is the third term? 1, 2, 3. The third term is minus 9y squared. This is our third term. What is the coefficient? So the coefficient is the number multiplying that, which is what? A negative 9. All right. Just like that. And 5.13, determine the value of the expression if x is 2 and y is what? Negative 1. Simply substitute into the what? Into this expression. In place of x, you're going to put 2. So that's 2 times what? 2 squared minus 8 times x. Our x is what? Our x is 2. Y is what? Negative 1 minus 9y squared, y is negative 1, all right, minus 7. So you substitute in place of x what represents our x. X is what? X is 2. So in place of x, you put what? A 2. And y is what? A negative 1. So in place of y, you put what? A negative 1, like that. Then you can simplify further. 2 squared, that's 2 times 2, which is 4. Then 4 times 2 is what? Is 8. A product on these 3. So if you multiply here, that is negative times negative, which is what? A positive. 8 times 2 is 16. All right. Then negative 1 squared, that's a 1, times negative 9, that's negative 9, minus 7. So on this stage, you can even just use a calculator, guys. 8 plus what? Plus 16 minus 9 minus 7 is going to give us what? 8 at the end. So that was the answer. When x is equal to 2, and when y is equal to what? A negative 1. All right, just like that. 5.2, expand, all right, the following expression. All right, if we check properly there on 5.2, actually, so that's 5.2, you are going to notice that the two brackets that we are given in the first place there represents a difference of 2 squares, a plus b into what? Into a minus b. That's a difference of 2 squares, which was taken from what? A plus b into a minus b was taken from a squared minus b squared. So you can easily expand using that concept. 2x squared, 2 squared, it's 4x what? X squared. All right, minus b squared, which is what? This or a, this or b. So 4 has to be what? Squared again, which is going to give us a 16. All right, minus, there is a bracket here, x is minus 3 squared, this one. So you are supposed to expand, in this case, 2 brackets, x minus 3 into what? Into x minus 3. 2 brackets. Using the FOIL method, you can expand this part, x times x, that's x squared, the first, then the inner, negative 3 times x, which is what? Negative 3x, then, sorry, the outer part. What did I do here? I wanted the outer part, which is negative 3x, then the inner part, negative 3x, then the last, negative 3 is what? Positive 9. So collecting like terms here, minus 3 minus 3 was going to give us what? Negative 6x plus what? Plus 9. So this is what you're going to get here, x squared minus 6x plus 9. Make sure that you simplify this properly. Then with this expansion, we can expand 1 over 2, half of this. So it is half of what? 4. What is half of 4? It is a 2. So that's 2x squared. Half of 16, half of 16, that's what? 8. But there's a negative, so it's negative what? Negative 8. So you can find half of that. Then on this bracket, you are supposed to expand it with the negative. That's why I've got the negative outside of the what? Outside of the bracket. So you need to expand each and every term inside this bracket with what? With a negative, just like the other part where you multiplied by what? By the 1 over 2. There is a negative, just like what? Negative 1. So that's negative 1 times x squared negative x squared, or negative 1x squared, if you want to write it that way. Negative 1 times negative 6, that's a positive. Negative, negative, positive. Negative 1 multiplies positive 9. It is going to give us what? A negative 9 at the end. And that is it, collecting the like terms. The terms in x squared, we've got what? 2x squared minus x squared. So 2 minus 1, that is going to give us what? 1x squared, which is simply x squared. All right, then we have got the terms in x. It is only this part where we have got x. So that's plus 6x. The constants, there is a negative 8 here as a constant. There is a negative 9 as a constant. So minus 8 minus 9, that's what? Minus 17. So this is going to give us minus 17. So that is the idea of this type of a question. Actually, in answering this, you are going to obtain this typical, all right? That is the typical way of answering, all right? So do revise as many questions as you can. 5.3, let us factorize the following fully. Factorize. You can see that here there are brackets already on 5.31. X into x minus 3 minus y into 3 minus x. Take note, when you're already given brackets, you are supposed to factor out the common bracket, but these two brackets, they are not the same. The first bracket is x minus 3. The second one is 3 minus x. They are not the same. Here x is positive, here it's a negative. They are not the same. Here minus 3, here positive 3, they are not the same. So what you can do is to rewrite the second bracket as the first one. Rewrite the second bracket as the first one. Remember, guys, I told you from your factorization that if you are given y minus x, you can factor out a negative and write x as a positive, y as a negative, the moment you factor out a negative. So if I'm given something like this, 3 minus x, I can factor out the negative. X becomes a positive, and this 3 will become what? A negative. By factoring out a negative, it is possible that we can rewrite the second bracket as the first one, as x minus 3. So it is going to be minus y in this case. Remember, here what's going to happen? You factored out a negative. So it's now negative times this negative, all right? So it is going to be positive y like this, all right? Then the bracket is now x minus 3. So you factor out a negative. The moment you factor out a negative, these brackets will be the same. But the negative now must multiply the negative, which was already outside of the bracket. There was a sign already. So it is affected by what? By the sign that we factored out. Not forgetting that for this case, if the two brackets are common as it is right now, they are the same, not before. Before they were not. Now they are the same. When it is like this, I can factor out the common bracket of x minus 3, remaining with what? With x here and here, remaining with what? Plus y in another bracket. That is the concept. So this is what you're going to have. You're done. Factorization is complete. All right, let us move on to another one, 5.32, where you are given 16x squared minus 1 over 9, a difference of 2 squares. These are perfect squares. So we can have this 16x squared minus 1 over 9. We know the square root of 16 is what? The square root of 16 is 4. So that's a perfect square. It is same as 4x squared minus 1 over 3. The square root of 1 over 9, I mean 1 over 9 like this. The square root of 1 over 9 is what? 1 over 3. It is the same as 1 over 3 squared. Remember, from our difference of two squares, if you're given 4x and this one, you are given a minus a squared minus b squared. It was taken from what? A plus b into what? Into a minus b. So the terms raised to the power of 2. In our case, it's what? 4x and 1 over 3. The square roots of these terms. So that's 4x. One bracket adds plus 1 over 3. Another bracket is going to what? Subtract. So you subtract the 1 over 3. So that's it, a difference of two squares concept. A plus b into what? A minus b. This is your A, this is your B. So from that concept, guys, we can simply apply our difference of two squares direct, obtaining the two brackets. All right, let us consider another part, which is a quadratic from this trinomial that you're given. We have got, right, we can even start with this, negative 2x squared plus what? Plus 36x plus 126 like this. And as you can see, the highest common factor, before we consider that this highest power is 2, we can factor out the highest common factor between the numbers, these numbers, the constants. And that's also avoiding working with a negative. So factor out, that'll be negative 2, the highest common factor between negative 2, 36, and what? 126. So this is going to give us negative 2 to negative 2. That is going to be a positive. This cancels, you remain with x squared. 36 to negative 2, that's a negative. 36 divided by 2, that's 18, 18x, 1, 8. All right, 126 divided by negative 2, that is going to give us a negative again, and that's negative what? 63. So this is positive to a negative. 126 over negative 2. So it's positive to a negative. It's going to give us a negative. So that's negative what? 63. So this is what you're going to have. Negative 2, we have got a quadratic here. From our concept of factorization, we do understand that we are going to have two brackets. Since the coefficient of x squared is 1, we've got 1 here as the coefficient of x squared. What are you going to do? You are simply going to consider this as x and this one as x. Then you focus on the factors of what? The constant term, the product of the constant term, which adds up to a negative 18. The constant term, which is negative 63. What are the factors? What are the factors, the products of this, which will add up to a negative 18, 1, 8. There are so many factors of negative 63, so many. But of these, where we are going to get a negative 18 is between 21 and a 3. So we must have it from 21 and a 3. So if we get a negative and another one, we put a negative here. So multiply this, you get negative 63. Multiply this, you get negative 63. But which part, when you add like this, you're going to obtain negative 18. It's between these two, negative 21 and 3. If you add Negative 21 plus 3, that's what? Negative 18. So these are the numbers that we need. Negative 21 and what? A positive 3. Your factorization is done like that, all right? So that was the concept easier like that, all right? Simplify the algebraic fraction on question number 5.4. All right, we've got an algebraic fraction that we need to simplify. In this case, there is a division. So remember the first thing, guys, get rid of that division. Introduce what? A multiplication. The moment you introduce a multiplication, know what's gonna happen. The second fraction, you must invert it. You must invert the second fraction. So it is going to be minus 2x to the exponent of 2 over what? The denominator 6x squared plus what? 18x, like that. So you interchange, introduce multiplication, interchange like that. All right, so that was going to give us from our factorization, since we have got our trinomial here, let us just consider two brackets. All right, this is x and this is x. Factors of what? Negative 18. Remember the concept, guys. This one is not going to change. Factors of negative 18, which adds up to negative 3. There are so many factors, but consider negative 6 and 3. All right, where you add, you're going to obtain a negative 3. That's between these two. Negative 6, positive what? 3. All right. In this, in the denominator, we've got two terms, 1, 2. So you can just consider the highest common factor, which is x. All right. The one that has got the smallest power is x. So x squared divided by x, that is x, minus 6x divided by x, that's what? A minus. All right. It's x. That's going to be just minus 6 like this. All right. Times. The negative is raised to an even number, it changes to a positive. So that's 2 squared, which is 4. All right. X is also raised to the power of 2. So that's x squared as a positive. Over what? Two terms. Just like here, there are two terms. You just have to consider the highest common factor, of which 6 is considered. Then x is also considered. So if you factor out 6x, it is going to give us what? 6x squared divided by 6x, that's x. 18x divided by 6x is what? Positive 3. So that's the concept. Remember to cancel as long it is common between the numerator and what? The denominator. Numerator to the denominator concept. So in our case, x minus 6 and x minus 6 can cancel. X plus 3 and x plus 3 can cancel as long it is the numerator to the denominator. All right. So in this case, we've got x times x, it's x squared. So it's going to cancel with this x squared. So you're left with what? 4 over what? 4 over 6. In the numerator, guys, you're left with 4. In the denominator, you're left with what? 6. Reduce this one by 2, divide by 2, that's a 2, divide by 2, that's what? A 3. So that was going to give us 2 over 3, the highest common factor, if you divide by the highest common factor of the two numbers. Just like that. So this is what you had, 4 marks. Okay, just like that. Question number 6. Solve these equations. We have to solve for what? For x from the following equations. The first one on 6.11, 5 to the exponent of x is equal to 1 over 125. 5 to the power of x, remember, 125 can be written in the base of 5 as 5 to the exponent of 3. All right, so you can use the calculator also to verify that 5 to the exponent of 3. On your calculator, you write 125 is equal to, then you press the shift fact button. So that's 5 to the exponent of 3. So get rid of this, write it on the top. Remember, 1 over x to the exponent of n is same as x to the exponent of a negative. If you rewrite it, getting rid of that 1 over, it's going to carry what? it is going to carry a negative exponent. If the bases are the same, considering that's an equation, if the bases are the same, it follows that the powers automatically will be the same. So in this case, x 5 and 5, they're the same. So automatically, x is equal to what? Minus 3. Therefore, x is equal to minus 3. You equate the powers from that concept. All right. Considering another question, in this case here, we can consider taking the 27x to the other side of the equation. So it is going to be written as 3x cubed minus 27x is equal to 0, so that we can properly factorize, considering the highest common factor, as we have got two terms. Between 3 and 27, you factor out 3. Between x cubed and x, that's x. So this is our highest common factor. Factoring out this, it is going to be 3x cubed over 3x. So that's x cubed divided by x. You're going to remain with the 2 of the x's here. So that's x squared. 27x over 3x, x and x cancels. 3 into 27, that's what? 9, and that's equal to 0. And looking into our equation, it is actually getting interesting, as x squared minus 9 is a difference of what? 2 squares. Remember, we talked about this before. A plus b into what? A minus b. So you're simply gonna need 9, the square root of 9, that's 3. So it's same as what? 3 squared. So it was actually going to be the 3x that you factored out before into the two brackets of the difference of what? Difference of two squares, which is the square root of x squared, which is x, all right? The square root of 9, which is 3. So one is going to add, another one is going to subtract. Our difference of two squares is being applied. So we are back to the product, guys. This is a product of three terms, this one to this one, giving us a 0 like that. So it means each of these three must give us what? A 0. It is either 3x is equal to 0, or this bracket of what? X plus 3 is supposed to be equal to 0, or the bracket of what? X minus 3 is equal to 0. So the first one is going to give us what? Divide by 3. Since it's a product, x is equal to 0 divided by 3. That's a 0, all right? 0 over what? Over 3. That's a 0. Or our x is equal to what? The 3 to the other side is going to change into a negative. Or our x is going to be negative 3 to the other side is going to change to a positive. So these are the values of x that you are going to have at the end. All right, x is equal to 0, x is equal to minus 3, or x is equal to a positive 3. These three, the order does not matter. The order, you start with a positive 3, negative 3, or a 0. The order does not matter at all. All right, so that is what we had on 6.12 from this equation. Let us consider question number 6.2, which is part of your word problems. You are given a word problem to consider. The perimeter of a triangle is 36 what? Centimeters. There is a triangle and its perimeter is 36 centimeters. The second side is twice the first side, and the third side is 3 more than the first. Guys, are we seeing that? The second side is given in terms of what? The first side. The third side is given in terms of what? It is given in terms of the first side. So what does it mean? It simply means we can have the first side as the unknown. Let the what? The first side be equal to x. So if the first side is equal to x, what about the second one? What about the second side? We are told that the second side is twice means what? Multiply by 2. So that's 2 times x, which is what? 2x. So the second side is 2x. And the third side is 3 centimeters more. 3 more, you add 3 plus that. So that's our third side. 3 more than that. So that's x plus 3. From what you're given, add 3. X plus 3. So these are the sides of the triangle. The first one, the second one, the third one, in terms of x. Then the question is, find the length of what? Of the sides. Find this side, the first, the second, and third one. So simply solve for x. How can you solve for x? We are given these in terms of x. And also the perimeter, where perimeter is the distance right round the shape, the perimeter of 36 centimeters. So it follows that if I take the first side, add to the second side, add to the third side, I'm going to obtain what? 36 centimeters perimeter, distance right round the shape. You form an equation from there, which you can solve for x. So this is same as 1x. So 1 plus 2, that is 3x plus, expanding this bracket is just like there's a 1 here. So 1 times x, that's 1x. 1 times 3, that's a 3 equal to 36. 1x plus 4x, I mean plus 3x plus 1x, those are like terms. So you're going to add 3 plus 1, that's what? 4x. So that's 4x is equal to, get rid of this 3, simply subtract 3 both sides. That was going to give us what? Minus 3 here, 33. All right, 36 minus 3, that's, yeah, 33. That's it, 33. So to find x, simply divide, as we have got what? A product here. So x is 33 over what? Over 4. 33 divided by 4, and that is 8,25. So that's 8,25. So if x represents the first side from this information that we have to say, therefore, the first side is going to be what? Remember, it is x. So if the first side is x, therefore, this is what we have here, 8,8,25, representing x. So the first side is what? 8,25 centimeters. These are given in centimeters, the perimeter. What about the second one? And the second side is given as what? The second side is given as 2x. So that's 2 times our x, which is what? 8,25. So simply multiply times 2. That is going to give us what? 16,5 as a decimal. So that's 16,5 centimeters. This is the second side. What about the third side from this information? The third side is given as x plus 3. Our x is what? 8,25, remember? So 8,25 plus 3 is what? That's 11,25 centimeters. If you simply add 8,25 plus what? Plus 3. That's going to be 11,25. This is the length of the third side. So these are the sides of the given triangle to give us the perimeter. And from the information that we're given about these sides to say the first one, the second one is related from the first one. The third one is also related from the first one. So let the first side be x. Then the rest can be obtained from that x. The second side twice, 2 times that. The third side, 3 more than the first side. Add 3 to the first side. 3 more than you add. All right, so that is the condition. So this is how these typical questions are given, as you just need to revise as much as you can as you are preparing yourselves for the upcoming examinations, upcoming tests that you are going to be writing. Are they assignments? This information is important because it covers both term 1 and what? And term 2. So do revise in as much as you can. So that is the condition. Let us revise as much as we can. So that was the last part of our question paper from what we had. So guys, this is it. Let there be light in our revisions. Let there be what? Let there be light in our revisions as we are revising. That's it, guys. Till we meet again.